Okay, we wrote today a pretty interesting looking integral. This one's from the Vienna Integration Bee 2024, problem 44. We have the integral of ln x minus 1 over 1 plus ln x all squared dx. Okay, this is a pretty tricky looking expression. It's like we're not used to seeing something quite like this. It doesn't look like a u substitution is going to work that well. It's hard to see how like integration by parts is going to work. You know, it's kind of tricky to work with natural logs, so there has to be some kind of trick to this. So one thing I did with this, I actually did do a u substitution on the ln x just to clean it up. It's an optional step. I think I'm going to avoid it this time. So what I'm going to do with this is actually just try to work with the algebra. And the thing is, if we do, without actually making that substitution, if you notice, if you think of this as like u squared plus 1 here, if you actually square the numerator, you're going to get a u squared plus 1 back. So if I just square out this numerator as it is, we're going to end up with natural log x squared. I'll square the minus 1, we get a plus 1. And then for the middle terms, we're going to have minus 2 natural log x. And then let's basically just leave this denominator. I'll reorder it. We'll write it as natural log x squared plus 1, but then the whole thing squared. So we'll write it like this, dx. But then from here, you'll notice if I break this into two integrals, if I kind of break it right here, then with this piece, we're going to get cancellation with this here. Actually, let's not break it into two integrals. Let's just break it into two fractions and leave it in the same integral. Kind of the same thing, but it's just going to work out better in the end this way. So for the first fraction, we're going to have this piece here over the whole denominator. And then for the second fraction, we're going to have this part. We'll write it like this, minus 2 natural log x over all this same denominator. But then I can take this, cancel all this here, and cancel one of these here. Then the thing to recognize here, if we look at this as the first power and this is squared, it looks like there's a chance that either the derivative of this is going to be this or really similar, so we can check that. Let me put a label on this piece, the first piece here, we'll call it g, and then we kind of hope that this is g prime. So coming over here, in order to take the derivative, I'm going to bring it into the numerator and write it as ln x all squared plus 1, but we'll write it to the minus 1 power like this. Then for our g prime, first we'll use power rule with this, bring the minus 1 to the front, bring back the same thing here. Subtracting 1 from the power, we get minus 2. Then we need chain rule on this. Derivative, we don't care about the 1 because that's going to be 0. Derivative here, this is going to be 2 ln x, but then we need chain rule again. Derivative of ln x is going to give me like a 1 over x there. But then let's clean this all up and get it back looking more like this. So if I distribute in the minus 1 to the 2 ln x here, we can have minus 2 ln x. I can have this x here and then bring this back into the denominator as ln x squared plus 1 all squared. But then the problem with this is we have almost everything that we have right here. We're just missing this x right here. So what I'm going to do is actually, if I just multiply that in, doing that, now this whole thing is g prime. So that's good. But then I don't want to change it, right? So like if I just multiply by, let's do it over here. If I multiply by x over here, this x over x is just 1. So now I haven't changed it. And what I'm trying to set up here is I want this to be the product rule in reverse. And so now we've got this other piece hanging out here. To make this work, if I can call this piece here f, so if we just say this is pretty simple, if f is equal to x, then what is f prime? That's just going to be 1. But the good thing about that is it's really easy to create a 1. I can just kind of and we have a 1 right there, but if I want all this to be g, I can just multiply in a 1 there, right? And then by doing that, I've just created the f prime right here. And so let me just try to make it clear everything that's happening with the product rule. For our product rule, if we have the derivative of two things, f times g, then the derivative of this is just going to be f prime g plus f g prime. And so what I'm saying is in our integral, we have that. We have our f prime g right here, our f g prime right here. The thing is, this is in an integral. So if we look at this as what happens when we have this type of thing inside of an integral, well, here we have the integral of a derivative. So the solution of this just needs to be f times g plus c. But looking at this, we've already identified our f, we've identified our g. So for our solution, we just need to put that together. So we're going to have x times this, but what's going to be 1 over natural log x squared plus 1, add a plus c, and that's it. Okay, there you have it. Good one from Vienna 2024. Thanks everyone for watching. Have a good day.